Grounding. That is a big reason for a lot of problems when direct connecting. Thank you for following me into the field. This particular section is a follow-up to our last video, which was on what do I choose? Direct connection, closed induction. In that video, we chose closed induction. So if you'd like info on that, go to the prior video. In this video, we're choosing direct connection. So to quickly walk you through my thought process, one, am I in a congested area? Yes. If we turn around, I'm going to make our camera lady do some work here. We've got water. We've got power. We've got TV. We've got phone. Woo, let's go back in circles again. I like making her do circles. Don't worry, I'm not going to run. So am I in a congested area? Yes, I'm in a congested area. So I don't really want to use direct connection if I don't have to. What am I here to locate? I'm here to locate this water main. Am I going to get a ring clamp around it? Well, as you can see by my already getting set up here for you, no, I don't think I'm getting a ring clamp around it. Is it part of an existing circuit? No, it's not part of an existing circuit. So it's not like TV or phone or a utility that's part of a functioning, working circuit. So I'm going to have to direct connect to it. How am I going to do that, and how am I going to do that in a safe and effective manner? Let me show you. The first thing that I'm going to do is I'm going to grab my receiver and I'm going to go to a radio signal. Woo, radio. And I'm going to come over here and I'm going to sweep. And you'll notice that is going to start going off maybe. Right about there. So you'll notice that that's a pretty congested area. Then I'm going to go to power and I'm going to sweep. And I'm going to see if I get a signal. I'm just turning down the gain. So that's a pretty congested area. So go ahead and back up now. So we don't want to ground in these areas because we are getting a signal here and we are getting a signal here. So what I don't want to do is to set up my ground right over the top of a utility. So if you come over here, it's going to be the same thing. If I'm locating this way and I sweep over here, which you don't need to show the machine for this one, there's a signal here and there's a signal here. So I don't want to put my grounding rod, or in my case mat, over that utility. What I'm going to do is come sweep over here, and you don't need to show the machine, and I'm noticing that I'm not getting any signals here. So as far as I can tell, I'm doing my due diligence to make sure that there's no utilities where I'm placing my grounding mat, patent pending. I try very hard not to drive ground rods into the ground. Grounding is about surface area, and we will do a video on horizontal grounding. So I'm going to put my ground rod or my ground mat here. I'm going to connect to my hydrant right here. This goes all the way through the center of the hydrant. Hydrants have lots of rubber insulators and washers, so you know you're probably going to have to use a higher frequency and a little more current to get through that mostly higher frequency. I'm connecting my positive lead there. I'm connecting to my grounding mat well away from where I'm going. Away, not aware. And I'm hooked up here on a 32.8. Now, we can go ahead and try to go lower, which is always a best bet to try. And we're going to need a little bit of current, I'm sure, to try to overcome the resistance in that line. Wow, that's a lot of milliamps. Let's see what happens. We're going to turn on our receiver, and we're going to make sure that our receiver matches the frequency. I think it was 8.19 on our machine. We're going to set our decimals or our gain here. I like to set it around 100. And we're going to walk away from our area. I like to get away from things. And we're going to locate and see what happens here. We can turn it down. So you can see we're getting a signal. You can see the null. Little difference in the null. Not bad. Peaks over here. Now I could mark this, but you can see it's a little bit jumpy. So let's go back to the transmitter and let's ask ourselves, why is it jumpy? Okay? So the utility I'm locating is not a complete circuit. It's a water line laid in the ground. It's a metal water line. It's got lots of insulators and conductors in it. So it makes sense that I might need to up my frequency a little bit in this case to help me out. So we're going to go over here and we're going to up it a little bit to a 32. And I'm going to go here to a 32.8. And now we're going to walk back down here and see if that gets rid of some of that jumpiness for us. Absolutely did. So there's our null right there, and it's coming together at the same spot as our peak. So you could go ahead and just mark the peak on this all day long. So I have a peak null setting going right now for the video so you can see the null. What I will often do for me is go to this graph setting, and you go back and forth. It'll show you the peak and the null, and they're agreeing. And that water line is right there. So the important things to remember when you have to direct connect to a utility is do a passive sweep before you place your ground. Make sure you're away from your intended path and your direction and all the congestion. And then when you're choosing your frequency, be aware that the higher you go, you can jump onto other utilities, but you may have to do that in order to get the current to behave the way you want to. Because remember, in this scenario, we're using the earth to complete our circuit, and we're in a congested area. So make sure your grounding mat is well away from where you're going to be locating, and don't put it on top of any other known utilities. Thank you.